Welcome to the PhysicsPlace, the place to learn about physics. And in this video I'm going to explain what position time graphs are, how you can make them and how you can read them. This is an example. As you can see, we have the position, we have the time, and we have a line here. And first I'm going to show you how we make such a graph. For that I use this example. We have a ball which has been falling to the ground, and as you can see it was measured what the position was, and we know what the time was, because to the right is a stroboscopic photo which was taken from a falling ball with intervals of 0.05 seconds between each photo, and the distances here are given in centimeters. So if you have something like this and we want to make a graph from it, we first have to make a table that looks like this. So we have a table and we will have the time in seconds. We have a starting time of 0.00 seconds, and then every time there is 0.05 seconds more, because every picture has an interval of 0.05 seconds. So now we have the time and we also need the position. Well, at the beginning the position was 0. We will do the position in meters, and this is given in centimeters, so we have to divide it by 100. The next one is 0.01, because that's the one divided by 100. Then 0.04, 0.09, and so on, and we can just write down all these positions in this table. And that looks like this. And from this we can make a graph. And it would look like this. Here we always have the time. So horizontal we always have the time, and in this case it's in seconds, just like in the table. And here vertically we have the position, which is in meters, just like here in the table. And we have made this from 0 to 0.5, as you can see here. And this one goes from 0 to 1, as you can see here. And now we can put all these points into the graph. So we put one point at 0, 0. Like here. Then the next one on 0.05, which is 0.01. So it goes a little bit up. And as you can see, these points you have to put in the graph, and it will look something like this. Now you're not done yet. Now you have to connect them. And you have to connect them with a fluent line. So don't connect them with straight lines, but just use a fluent line and it will look like this. So now we have made a position time graph from the movement which we saw in the photo in the previous slide. Here you can see a straight line. When you have a straight line, the object is moving with a constant speed. So every time the time goes by, the same amount of distance or the same position is being added. So we're talking about a constant speed. If you have a line like this, which is going horizontal, then while the time goes by, no position is added. So it stays at 12 meters. That means that the object is stationary. And so if you have a line like this, a horizontal line, then the object is stationary. And finally this one, I think this one is the most difficult. If you see a line like this, the object is decelerating. Because you can see that first, when the time is going by, distance is being added, but when the time goes by further, there's less and less distance added until here at the end, and the object seems to be stationary. So now the object is decelerating. It's going slower and slower and slower until finally here it's stationary. And so there is a negative acceleration. So one of these two, or we are talking about deceleration or a negative acceleration. Another thing you need to be able to do if you have a position time graph is to calculate the average velocity. And I will show you now how. For the average velocity, we need two things. We need the displacement. You can get that from the position, and we need the time, which you can get here. We can do that for every of these motions individually. So for motion A, for motion B, and for motion C. And we will start with motion A, and we will use this equation. We have the velocity, and we divide the displacement by the time. So we need to get that information. Well, the displacement is given here. It goes from 0 to 4, so the displacement is 4 meters, and the time goes from 0 to 2, so that's 2 seconds. We divide them and we have 2 meters per second. So the velocity, average velocity of this motion is 2 meters per second. The same can be done for B. We end at 4 meters and we begin at 4 meters, so the displacement is 0 meters. We end at 5 seconds. We started at 2 seconds. As you can see here, 5 seconds is where we ended. We started 2. So the time is 3 seconds. So we divide 0 by 3, which is 0 meters per second. And that's of course correct, because you can see here that it's stationary. So there is 0 velocity, 0 meters per second. Now this one, again, we have to use the same equation. 24, because it ends at 24 here. It started at 4, so minus 4, so the displacement is actually 20, because from here to there we went 20 meters up. It ends at 12 seconds. It started at 5 seconds, so 12 minus 5 is 7 seconds. We divide them and we have 3 meters per second. That's the velocity of motion C, and be careful, it's the average velocity, because as you can see the velocity changes here, but we now calculated the average velocity. Another thing you can do from this graph is you can determine the average velocity of the entire motion, so from beginning to end. Some students want to do this by adding these three together and dividing it by 3, thinking that they have the average velocity then from this entire motion. And that's incorrect, because as you can see, motion A was only 2 seconds and motion C was a lot more, like 7 seconds. So you cannot simply add them together and then divide by 3. You have to calculate it again from the beginning. Just like we did motion A, B, and C, you now have to do the entire motion. So to calculate the average of the entire motion, you need the total displacement divided by the total time. Well, as you started from 0, you ended at 24, so the total displacement is 24 meters. You started at 0 seconds, you ended at 12 seconds, so the total is 12 seconds. And if you divide it, it will be 2.0 meters per second. That will be the velocity, the average velocity of the entire motion, and not the 1.7 which we had previously. So remember, you cannot simply add them together. You just have to start over with the displacement and the time for the entire motion. That's it. You should be able to make your own position time graphs, and you should be able to read them and to calculate with them. If you found this video helpful, please let me know by liking it, and of course subscribe for more videos. Thanks for watching.